Today we will explore the geomorphology of the Barron River Delta, focusing on its riparian zone, the dynamics of flooding and the coastal effects. Let's dive into this fascinating landscape. The Barron River Delta is located in far north Queensland, Australia, where the Barron River meets the Coral Sea. The Barron River originates on the Atherton Tableland, 900 metres above sea level. Before passing over the Barron Falls and then travelling a further 5 kilometres through a gorge on the fringe of the tableland. It then reaches Camarunga, which is the apex of an alluvial fan delta. The delta extends north from Camarunga to Yorkeys Knoll and south to the Cairns Airport, an area of about 40 square kilometres. This delta was formed by sediments deposited as the Barron River's flow slowed upon reaching the sea, creating a range of geomorphological features. Originally tropical forests, the land was cleared in the early 20th century for predominantly agricultural purposes. The riparian zone is the interface between the land and the river. In the Barron River Delta, this zone is crucial for erosion control. The plant roots stabilise the riverbanks and prevent erosion. The buffering of nutrients and sediments by filtering sediments and nutrients from the adjacent overland runoff, shading streams, reducing solar radiation inputs to the river, and ecosystem support, providing habitat for wildlife such as birds, fish and insects, and water quality, filtering pollutants and sediments from the runoff before they enter the river. The Barron River Delta formed through sediment deposition. The key features include distributary channels. They are channels that spread out from the main river, transporting sediments, mudflats and sandbanks, areas where the sediments accumulate, visible especially at low tides, and estuarine wetlands that are important for biodiversity and natural filtration. Flooding is a significant geomorphological process in the Barron River Delta. Some dynamics include high rainfall, intense rainfall that increases the river discharge leading to the overflow, the flat terrain. The delta's low-lying flat topography allows water to spread widely, and tidal influence. High tides can exacerbate flooding by pushing seawater into the delta. Flooding impacts the riparian zone in several ways. Erosion. Strong floodwaters can erode riverbanks, damaging vegetation and altering habitat. Sediment deposition. Excess sediments from the floods can smother plant roots and disrupt ecosystems. And pollution. Floods can carry pollutants into the riparian zone, affecting water quality and wildlife. Flooding also affects coastal areas of the delta. Erosion. Increased water flow can erode coastal landforms, affecting beaches and coastal vegetation. Sediment redistribution. Floods can carry river sediment into the coastal zone, altering coastal morphology and habitats. Sea level rise. Combined with flooding, rising sea levels can further impact coastal stability and ecosystems. In December 2023, following Cyclone Jasper, there was an extreme rain event. This event was caused by the cyclone stalling inland of Cairns over the Atherton Tableland. As a result, there was heavy rainfall that fell continuously over a 48-hour period. 1900 millimetres or 1.9 metres of rain fell during that period. The Barron River peaked at 4.4 metres, well above the 1977 record of 3.8 metres. It was estimated that there was 6,440 cubic metres per second of water passed the river gauge at Myola every second at the height of the flooding. As the flood waters reached the Barron Delta, the water level rose quickly, and both agricultural and residential areas were quickly inundated. The Cairns suburbs of Machen Beach and Holloways Beach were especially badly impacted by the flooding of the Barron River, with many properties, roads and public areas damaged or destroyed, with residents having to be evacuated. With over 941 properties damaged by floodwaters and a 100-metre section of the esplanade at Holloways Beach being washed away, as the flood burst through the suburb, isolating homes in the beachside suburb. As a result, 1,000 tonnes of flood-affected hard waste was collected directly from homes, and over 475 metres of water piping and 237 metres of sewer mains needed to be replaced or installed. This flooding event has estimated to have a $390 million adverse impact on the Cairns economy, with over $740 million in insured losses due to this event. In an attempt to mitigate the impacts of flooding and coastal effects, various strategies are employed. Flood management, such as engineering solutions like levees and floodways, in an attempt to help manage the floodwaters. Riparian restoration, planting native vegetation to stabilise banks and improve water quality. And coastal protection measures, measures such as seawalls and beach nourishment to try and protect against coastal erosion and sedimentation. Looking forward, climate change and its associated effects poses significant challenges. Rising sea levels, increased sea levels could heighten the flood risks and exacerbate coastal erosion. Extreme weather with more intense storms may increase flood frequency and severity. The need for adaptive management, where ongoing adaptation and monitoring are essential for effective management and protection of both riparian and coastal zones. A recently released report into paleo floods in the Barron River concluded that in the past there has been floods twice the size of the December 2023 event. By identifying imbricated boulders in the Barron River Gorge and then taking measurements of these boulders, researchers were able to calculate the mean flow velocity needed to initiate boulder movement. By using both empirical and theoretical equations, the authors of the report were able to reconstruct flood magnitudes of the Barron River of over 16,000 cubic metres per second. These numbers are 2.5 times that of the December 2023 event. In summary, the Barron River Delta is a dynamic geomorphological system with a critical riparian zone, that is influenced by flooding and coastal processes. Understanding these factors helps us to manage and mitigate their impacts effectively. By implementing strategies such as increasing public and civil awareness of the flood risks and the adoption of early warning systems such as installing flood cameras will assist in the mitigation of what are inevitable flooding events. Thank you for listening to this presentation.